Hello, my name is Tyler Senja, and I'll be presenting Penn State's Student Space Programs Laboratory's work on Oasis. SSPL is an undergraduate research lab under the supervision of Dr. Sven Belin that aims to give students education and experience, as well as contributing meaningful scientific research. SSPL's current project is the development of LIBS technology applied to the quantification of lunar water resources, which we've named Oasis. The ability to find and use water resources on the Moon will be crucial to the long-term habitation goals set by the Artemis program, which aims to land at the lunar South Pole where there could be pockets of lunar water in permanently shadowed regions. Laser-induced breakdown spectroscopy uses a laser pulse to induce a plasma from target sample material. The light given off by this plasma is collected by a spectrometer, where the spectra can be analyzed to determine the sample's elemental composition. Oasis uses a pulse 1064 nanometer laser to induce this plasma, and the spectra is collected using an Ocean Insight Flame T spectrometer at a range of 30 centimeters away. We believe laser-induced breakdown spectroscopy will be key to locating and quantifying lunar water resources for a number of reasons. First, you can collect a large number of samples, with a very low cost per sample collected. Second, there is no need for mechanical collection of samples for analysis. There are no grabbing arms, buckets, shovels, or scoops. Just point and shoot at whatever you would like to sample. Finally, LIBS can sample the same point multiple times, producing a slight drilling effect that allows for a layered analysis of lunar geology. Oasis started last year during the 2020 NASA Big Idea Challenge, where we proposed the payload pictured on the left. We'd like to thank them for the opportunity that kickstarted this research. As I stated earlier, further work on Oasis will be focused on developing LIBS as an analysis technique in general, and not just development of a payload. Because of the COVID-19 pandemic, development of Oasis was fully remote with very limited lab access and testing available. Thankfully, folks at the Naval Research Laboratory were able to take our instrumentation and run a test for us, which provided valuable feedback. To start, some good news is that our laser was able to deliver the power density required to produce plasma in a terrestrial atmosphere. We're using a 10x Galilean beam expander and a focusing lens with a focal length of 30 centimeters to achieve this power density at 30 centimeters away. You can see some plasma being formed from some GISC1A simulant regolith in the left photo, and we were lucky enough to record a 5 Hz firing pattern that also produced visible plasma. Please do note that in both of these photos the ablation is occurring with ambient light. However, when we did collect spectra, we did darken the environment. Another important item of feedback we received during testing was that our collection optics needed some serious redesigning. Spectra collected during testing contained no useful data, and we believe the most likely issue that caused this is misaligned optics. However, another possible issue is the focal length of our collection optics. We initially believed that collecting collimated light from the plasma would be enough to detect in a dark environment. However, we will be redoing our collection optics to instead focus on the actual point of ablation instead of staring to the distance and relying on the small amounts of collimated light. Once these issues are resolved and our instrumentation is working in terrestrial atmosphere, we will be able to run tests in thermal vacuum chambers at Penn State to achieve a low pressure environment, which will be crucial to developing LIBS for lunar applications where the effects of low pressure on the induced plasma present a number of challenges. Hopefully vaccination rates and a safe return to in-person activities will allow students in SSPL to continue developing LIBS technology. Thank you all for listening.